find the solution of this differential equation at x equal to 0. Again, we got to define whether x equal to 0 is a point ordinary point or singular point. If this is a singular point, we got to define it again whether it's a regular or irregular singular point. So in that case, we got to write this differential equation in the term of px and qx. In order to do that, we got to make the coefficient of our second derivative term to be equal to 1. So from this, we get px is equal to minus 1 over x and qx is equal to 1 minus x over x squared. X equal to 0 is a what? Ordinary or singular? Singular point. From this, we know that x equal to 0 is a singular point. So next, we got to consider whether what would be the type of our singular point. Is a regular or irregular by consider this term and x sine So by these two criteria, then we can say that x equal to 0 is a regular singular point. In that case, we are going to find r. So we know that we got to assume y is equal to summation x equal to 0, n equal to 0 to infinity, an x minus x0 to the power n plus r. So that means we've got to know the value of r. So to find the value of r, we can start with the integral equation. Our integral equation saying that r times r minus 1 plus 3 0r plus q0 equal to 0, where p0 is equal to limit x approaching to 0 xpx. What is our xpx? Our xpx is equal to minus 1 and q0 p0 equal to minus 1 and q0 is equal to 1. And then we just plug p0 and q0 back into our integral equation. So we would get minus r plus 1 we got to value of r which is 1 and 1. So that means the difference between r1 and r2 is equal to 0. It's the case 2. For case 2, we know that our y1 equal to our y2 is equal to y1 ln x minus x0 plus summation n equal to 1 to infinity bn x minus x0 to the power of n plus r 1, where b0 must not be equal to 0, or we can say that that is our two answer. So we are going to find the first answer first. Okay, in order to get the first answer, the thing is that we are going to use our this y to get the Lagrange relation. So we assume our y is equal to n plus r. You don't need to plug the value of r this time. Okay, and then because we are going to put this y into our differential equation, and our differential equation is we have the second derivative of y, so we got to do the first and second derivative of our y here. So we get and then we just plug it into our differential equation. Got what x squared x squared times the second derivative of y minus x times the first derivative of y and then plus 1 minus x times y. And then again, what we are going to do next is just that we have the x term there, x squared terms there. We are going to combine the x squared term with the term of x to the power n plus r minus 2. So we get for our second term, we are going to combine the x here with the x to the power n plus r minus 1. And this term, we are going to split it into two terms. And the first three terms, we have x to the power n plus r the same. So we are going to divide these three terms together. And now these two terms, we cannot put them together because our x have different power. So we got to use the shift of index in order to make the power of the x to be equal. In that case, we are going to make the x to the power n plus r plus 1 to be n plus r. Okay. By doing that, our second term is replaced n with n minus 1. Now we have the same x to the power n plus r. But the thing is that it's not begin at the same n yet. The second term is begin at n equal to 1. Okay, in order to combine these two terms together, we've got to plug the n equal to 0 to the first term. So if we put n equal to 0 to the first term, we would get what? R times r minus 1 minus r plus 1 a0 x to the power r. Right? And then the rest of the term we put as a summation n equal to 1 to the infinity. Now our second and third term have the same power and begin at the same point. And if you take a look at our first term here, if we suddenly put a 0, then you would know that this is a initial equation. มันคือสมการดัชนีถูกไหมคะตัวนี้คุณเซตให้มันเท่าศูนย์ปุ๊บมันคือสมการดัชนีนั่นเองเนี่ยซึ่งถ้าเกิดคุณไปดูเนี่ยมันจะเหมือนกับสมการดัชนีของเรานะคะเพราะนั้นตัวนี้เนี่ยมันคือ initial equation นั่นเองเซตเท่ากับศูนย์นะคะเซตเท่ากับศูนย์ก็จะกลายเป็น initial equation เหมือนไหมเหมือนไหมที่เราทำเมื่อกี้เหมือนนะคะเนี่ยดูเดี๋ยวฉันให้ดูเนี่ยค่ะที่เราเซตมาเห็นไหมคะเหมือนกันเลยนะคะแค่ไปเซตให้เท่ากับศูนย์ก็ใช่แล้ว Now what we want is just that we are going to combine these two terms together in order to get the reference relation. we are going to do the comparing of the coefficient. The first one we get initial equation, and the second one we'll get the recurrence relation. This is n greater than 1, or we say that a n is equal to a n minus 1.